Hey everyone, it's that math magician, and on this video we're going to take another look at a right triangle and an unknown side and trying to determine that side using our trig functions. Now hopefully you saw my introduction video on sine, on cosine, and on tangent, and if you haven't, you might want to go and watch that video before we jump into this problem, because I show you and explain to you how we get sine, cosine, and tangent and how we can use it to solve these problems. So now that we're looking at this right triangle, we see that we do have a reference angle. We have a reference angle of 27 degrees. We see here that we have a side of 17 units, and we do not know the side here of x. So again, this is a problem where we do want to try and solve for x using either sine, cosine, or tangent. So let's jump right into this problem. I'll go through and explain to you the steps on how to label the triangle, how to figure out which trig function to use, right? Are you using sine, cosine, or tangent? And then we will actually solve for x. So looking at my reference angle here, I have a reference angle of 27 degrees. The first step that I always do when I'm trying to label my right triangle is I draw an arrow going straight across to the opposite side of the right triangle, and I can label this as the opposite side. Now we notice here I do not have the opposite side. There's nothing there that we care about. There's no variable, there's no number. The opposite side here is of little use to us, okay? I do though see that if I trace my right angle here, I'm labeling that right angle with an orange color. I trace that because it points to the hypotenuse side. So now I know that x here represents the hypotenuse side, which means then that my third side over here, the 17, that is the adjacent side. So looking at this triangle here, I have the adjacent side, I have the hypotenuse. The only trig function that uses adjacent and hypotenuse is our friend cosine. So now I know that this is a cosine problem. So now I can start to solve this using cosine. So to set up my cosine ratio, I need to first write cosine of my reference angle. My reference angle here is 27 degrees. So I write cosine of 27 degrees equals a fraction, right? A fraction of sides or a ratio of sides. And we know for cosine that that ratio is adjacent over hypotenuse. So I take the adjacent side of 17, and that becomes the numerator. The denominator of that fraction becomes the hypotenuse, which is x. So I now have a ratio, a trig ratio set up. I have one variable, it's x. I can now cross multiply and solve and determine what that unknown side is. So to cross multiply, I put my cosine of 27 degrees over 1. And then I want to start to cross multiply. So I have to, whoops, wrong one. I need to take x times cosine of 27 degrees. And I write that out as x times cosine of 27 degrees. Now I once had a student ask me, why don't you put the x next to the angle? And the reason why I don't put the x at the end of cosine of 27 is because to me, that looks like the cosine of the angle 27x, right? That looks a little confusing. It looks like the x is a part of the angle when we write the x at the end. So to alleviate that problem, I always write the variable in front of the trig function, in front of sine, cosine, or tangent, just so we don't get confused and might see that as 27x. So I have x times cosine of 27 equals, let's cross multiply the other side, 17 times 1. So that equals 17. So I do have to do one more step before I can use my calculator, because right now I don't have x by itself. And you might have noticed in some of the previous videos, normally at this step, we can just enter in our calculator what we have in our expression. But if you notice here, x still has cosine of 27 degrees on it. We need to get rid of that. We want x by itself. So to get x by itself, I'm going to divide both sides by cosine of 27 degrees. By doing that, the cosines on the left cancel to a 1, and I'm left with just x equals 17 divided by cosine of 27 degrees. Now, this problem required an extra step, and the reason why is because the variable of x was in the denominator. When x is in the denominator, when your variable is in the denominator, you're always going to have to take this extra step of dividing out the trig function. It's just an extra step. It's nothing too crazy. But what that means is you end up dividing those two sides instead of multiplying. So at this step now, I just need to get my calculator, enter that expression in, and I will now know what x equals. So I'm going to go ahead and open up my free online scientific calculator by Desmos. It's at desmos.com/scientific. You can use it on your browser, on your phone, or your tablet, or even your computer like I'm doing now. And it's free to use, so I'll put that link in the description box so you can use that if you need to. I found that using the calculator on your iPhone or your Android phone can get kind of buggy sometimes. So instead, I just use this calculator because it's very nice and easy to use. So I need to enter in 17 divided by cosine of 27 degrees. So I type in 17. I hit the division button. It creates the fraction for me. So now I type in cosine of 27 degrees. I hit enter. And we find out that that unknown side for our right triangle is 19.0. Let's see, that 5 there is going to round this 79 to an 80. So this is going to make 19.080. That is the unknown side of our right triangle. That is the hypotenuse. That's what x equals. Okay, and we solved that using cosine. We used cosine because our reference angle here determined we had an adjacent side and the hypotenuse side. Now before this video ends, I do want to show you one other way that you could have solved for x. Because whenever you have a right triangle and you're using a trig function to solve for an unknown side, you actually always have two different ways of solving it. And to show you that, what I have to do is I need to explain to you that we had 27 degrees as our reference angle. Now, when we used 27 degrees, we had the adjacent side and we had the hypotenuse. But what we could have also done is we could have also have used this other angle here that's unknown at the moment. We could have also used that as our reference angle. And to find that angle, remember that triangles add to 180 degrees. I already have a 90 degree angle. I have a 27 degree angle. So I could just use my calculator and do 180 minus 90 degrees minus 27 degrees to find that that missing angle there is 63 degrees. So if I wanted to, I could actually solve this problem based off of that 63 degree angle. What if I instead now did not focus on the 27 degrees and I use 63 degrees as my reference angle? I think my triangle is going to change a bit. And by change, I mean the label is going to be a little different. The hypotenuse stays the same. The hypotenuse never changes in the triangle. But do you guys notice now that 17 is not the adjacent side? If I draw my line going across from my new reference angle, we see that 17 now becomes the new opposite side. And now I see that I have a right triangle where I know the opposite side and the hypotenuse. This means that this is now turned into a sine problem. So I want to show you that you can solve this problem with either cosine or with sine. It just depends on which reference angle you're using. So let's go ahead and quickly do this so we can see if it actually works. So sine of my reference angle. Again, we're not using the 27 degrees here anymore. We're now using this 63 degree angle in my top left corner. So I'm going to write sine of 63 degrees equals, for sine, we do opposite over hypotenuse. So opposite over hypotenuse means that we will have 17 over x. And you see here that again, we have a trig function set up. We got our sine ratio ready to go. We just need to put that left side over 1, cross multiply, and we can see what x equals. So I'm going to do that. I'm going to put sine of 63 degrees over 1. I'm going to cross multiply. Let's see. 17 times 1 will create 17. And then I'm going to have x times sine of 63 degrees. So I end up with x times sine of 63 degrees. Just like with this example up here, I need to do one last step, and that is I have to divide both sides by sine of 63 degrees because I want x by itself. I divide by sine of 63 degrees. The left side cancels. I'm left with just x equals 17 over sine of 63 degrees. We can now put that into our calculator and see, did we get the same result when we did cosine? So I'm going to open up my Desmos calculator here, and I'm going to type in 17 divided by sine of 63 degrees, and look at that. You see our first problem here on the top, our second problem that we're now using a different angle. Those two numbers are exactly the same. They are exactly the same because we are solving for the same side of this triangle. The problem isn't different. We're just using two different methods to help us solve for it. Okay, and I want to make it very known to you guys that whenever you are trying to solve a trig function, there's always going to be two ways you can do that. Because you can use both angles in that triangle as a reference angle. With cosine, we use 27 degrees as our reference angle. For our sine problem, we switch to the 63 degree angle. Both are right. Both are 100% correct to use. It's just up to you which one you want to use. It's that math magician, and I'll see you on the next video.